Support handout number 11. Problem number 1 asks me to add or subtract these fractions. I just need to make sure I have a common denominator. Of course, part A is very easy because I do. The x is the same in both, and so to subtract these fractions, just subtract the tops. 5 minus 17 is negative 12, and keep the denominator the same. Negative 12 over x would be the final answer. Letter B, I need to obtain a common denominator. The first one is 4 times x. The second one is just x. I can fix the second one by multiplying by 4, and as long as I do that top to bottom, then I have an equivalent fraction there. This becomes 1 over 4x plus 24 over 4x. And now I can add the tops, 25, keep the bottom the same. Let's see, do I have any reducing to do at the end? I don't. 4 and 25 don't share any common factors, and so here would be the answer. Part C, I have a 5 and an x in the first denominator and a 10. Of course, 10 is 5 times 2, so I'm thinking I probably need a 2 over here to make that 10, top and bottom. But then the other one is going to need an x to match the x of the first one. And now I have a common denominator. It would be 6 over 10x minus x over 10x. So I subtract the tops. Now those are not like terms, so the best I can do is just write it down, 6 minus x. The bottom stays the same. Because of the subtraction in the top, I am not looking at factors, therefore I can't do any reducing. This is the final answer. Problem number 2, I want to do some simplifying. Letter A looks like it's all about dividing out common factors. Everything I'm looking at here on the top or the bottom is a factor. They're all being multiplied. With the numbers, I have a common factor of 9 that I can divide out. With the x's, I have 2 x's on top, x times x, and 4 of them on the bottom, x times x times x times x. So the 2 on the top divide out 2 of the ones on the bottom, leaving me with the other 2 still left. And then the y's, well, I have 1 on the top and 1 on the bottom, so I can divide those out. And so when all is said and done, the only thing I have left on the top is the 2. And on the bottom is the x squared. 2 over x squared would be the final answer. Letter B is a fraction multiplication problem. I don't need a common denominator. I should look for cross-canceling opportunities, but I don't have anything. I only have numbers on the top and letters on the bottom, so all I would do is multiply across. 3 times 4 is 12. X times x squared would be x cubed because you'd have 3 in all, so 12 over x cubed. And then letter C is like part A, where I'm dividing out common factors. A negative divided by a negative is a positive. And then 14 actually goes into 42. So I can divide out the 14 from each number. That's 1 on the top and 3 on the bottom. And then as far as the x's go, let's see, 4 on the bottom, 5 on the top. So all 4 of these will get rid of all but 1 of those x's. And all I have left is x on the top and 3 on the bottom. Problem number 3, we want to rewrite each of these trig expressions in the shortest, simplest way possible. This often involves taking advantage of known identities. Letter A, when I see a 1 and a sine squared, of course, what I think of is the Pythagorean identity. Sine squared x plus cosine squared x equals 1. Is there a way that I could rearrange this so that 1 minus sine squared x was on one side of this thing? And the answer is yeah. As long as I moved this to the other side, then it would say cosine squared x equals 1 minus sine squared x. Well, perfect. 1 minus sine squared x then is equivalent to cosine squared x. And so we've written it shorter and simpler than it was before. Letter B, cosine x over sine x, that is directly one of our quotient identities. That is just equal to cotangent x. Letter C, tangent x over cotangent x. When I look at this one, what occurs to me is that tangent and cotangent are reciprocals of each other. There's not really any reason for me to leave a cotangent on the bottom when I could just as easily reciprocate it up to the top. In other words, tangent x divided by cotangent is the same as tangent x times tangent x, which simplifies to tangent squared x. And this would be the simplest way that I could write letter C. Part D, this is going to involve those negative angle identities. I'm going to ignore that minus sign in the front for the moment and just concentrate on that box, because that box, sine of negative x, according to the negative angle identity, is equal to the negative of sine x. I'm just applying that identity directly. Then after I do that, I'll deal with that negative that was in the front. That negative will combine with the other negative to result in a positive. The negative of negative sine x, of course, is just positive sine x. Same thing in letter E. Let me concentrate on this green box because that's the part that connects to the identity. I have that negative that was out there. The negative angle identity for cosine says cosine of negative x is equal to just cosine x. When I put this all together, then I don't have two negatives, I only have one, and so the final answer here will just be negative cosine x. Letter F, I have sine x times secant x. What occurs to me on this one is that I could take that secant x and reciprocate it down to the bottom as cosine x. Essentially, I've taken the reverse step from what we did in part C. And then now that I have sine x over cosine x, of course I recognize that as one of the quotient identities. That's just equal to tangent x, which would be my final answer. As long as the pieces are being only multiplied and divided, in other words, as long as there's no adds or subtracts, you can always do this reciprocation trick, and it often creates a simpler expression. Finally, problem number 4, we're being asked to do some quick multiplying here from algebra. Part A looks like a distributive property problem, so 2x times 3x squared would be 6x cubed. Then I've got a minus, and 2x times 4x would be 8x squared. Those are not like terms, and so that's as good as it gets. Part B is what we call a FOIL problem. I do the firsts, so 2x times 3x would be 6x squared, and then the outer, 2x times 7 would be 14x. The inner looks like minus 15x, and the last is minus 35. Those middle two terms are like terms, so I can combine those. 14x minus 15x would be minus 1x, or just minus x. And I've got the minus 35, and I'm all set. And then letter C says, be careful, you can't distribute exponents when you have adds or subtracts. So the only way you can work this one out is to think about what it means to square something. Squaring just means multiply it by itself. And as soon as you write that down, you realize, oh, this is just another FOIL problem. Let's see if we can do it all at once. I've got x times x is x squared. The outer is going to be 3xy, but the inner is going to be another 3xy, so that'll make 6xy in all. And the last appears to be 9y squared. None of these are like terms, and so I'm all finished. Soon we'll be doing this kind of algebra with trig expressions.